Okay, WHS, welcome back. I still got a little bit of voice left, so I'm going to keep doing videos here today. And I'd like to show you today, we talked about parabolas being a U-shaped graph. The most important point on a parabola is called the vertex point. Now you remember vertices for angles is where the rays took off from? Kind of the same idea with a parabola. When you draw a parabola, that point there at the very bottom, or if it opens down at the very top, is called the vertex point. Okay? Very important point because if the parabola opens down, it is the maximum value of the function, and if it opens up, it is the minimum value of the function. So when we talk about like what's the maximum height of an object launched vertically, and the heights form a parabola, when you graph the heights, the max height would be at the vertex point. So we want to be able to find the vertex point. Now, one of the forms for quadratics is standard form, and that's where it's kind of all laid out. Y equals ax squared plus bx plus c. How in the world would you find the vertex point of a parabola from that form? And there's a pretty easy answer to that. What you do is you find the x-coordinate at the vertex point, and to do that, you actually take the opposite of whatever this b coefficient is, and you divide by 2a. And that gets you started to get that vertex point, the coordinate for that. So if I have one here, I look at this standard form quadratic. A is 2, B is 8, and C is negative 12. Now C is not going to come into play on this today, but B and A are. So knowing that the x-coordinate of the vertex is gotten by taking negative b over 2a, I could look at this and say, okay, negative b would be negative 8, or the opposite of positive a, which would be negative 8. And then 2 times a would be 2 times 2 down there. So it looks like I got negative 8 over 4, which is negative 2. And that is the x-coordinate of my vertex point. Okay, so that's the deal. Now to get the y-coordinate, you will have to put negative 2 into the function and just get it. So y equals 2x squared, positive 8x, negative 12. Put negative 2 in here. Now y'all can do arithmetic. You don't need me to do arithmetic for you, I don't think. That's 8, that's negative 16, that's negative 12, so I believe my Minnesota math is right, that's negative 20. Okay? So I found the very, in this case, the very bottom of this parabola. At negative 2, negative 20, this parabola opens up. You can see A is positive. So we would find the minimum value of the function would actually be negative 20. Okay? At the very bottom of that parabola. Alright, so I got a couple more quadratic equations here, and I want to be able to find that vertex point so I can find the maximum or minimum of the function. Alright, so here's this one. And what's interesting here is you've got a squared term and you've got a middle term. There is no C term. So you still have an A. A would be 1 and B is negative 14. The x-coordinate at the vertex, got to remember this, be negative b over 2a. Which would be the opposite of negative 14 is 14 over 2 times a is 2. So I'm getting 7 for that value. So the x-coordinate at the vertex is 7. If I put that in there, I believe I'm going to get 49 negative 98, which is negative 49. So that parabola is way down there at 7 negative 49. It opens up. This represents a minimum again. Okay? Now if you look at my third quadratic here, it's quadratic because of the squared term. There is no middle term. Okay, now you got to be smart on this. If I say, how can you have a quadratic and identify what b is when this isn't even there? Well, what would b have to be for that not to be there? And the answer is 0. Okay? So b is 0. So when you go and you do the x-coordinate at the vertex, and you go, let's see, negative b, well, b is 0. It's 0, and I don't really care what this is then. It's going to be 2. So the x-coordinate at the vertex is 0. So 0, and you put it in there, and you'd have y would be negative 16. Okay? Okay. Now, there's one other form you're going to see for quadratics in, and it is called vertex form actually. And vertex form is where the quadratic is written in this model. A times x minus h or plus h squared, and then you might have something back behind there. But you're not going to see the power right on the letter. It's going to be attached onto a quantity. And essentially what you need to think of, this is actually a great form to figure out the vertex. What you need to understand about vertex points, and I did this in another video, is it's the start of the graph. So I always say the starting point is ground zero for a graph. So what would it take to zero out x in the equation? And when you figure that out and you put that in there mentally, what would y be? So if I said, look right here, what would x have to be to turn this thing here into zero? And you see, x would have to be 4. It would be the opposite of this. So the vertex here is just right in front of you. You got to say what zeroes out the independent variable, which is the x variable here, and it's going to be 4. And when you put 4 in there, the output is 1. Okay? So, if you are looking at that, that's over here, the parabola opens up. Okay? So it says identify the max or min value of the function. You've just got the minimum. The minimum, all these points, all of them right there. That's the right there is the minimum. Okay? And every number you can imagine to put in for x, the smallest output would be when x is 4, y is 1. Okay? Now, that's called vertex form. Now this is an entirely different animal. This is actually factored. It's factored form. And this is not going to find you the vertex instantly, but it will allow you to find it. And essentially, what factored form can get you, it can get you the x-intercepts of the graph. Okay, now the x-intercepts, if you remember what x-intercepts are, they're on the x-axis. And the key to that is on the x-axis, y equals 0. So I'm kind of saying, what would x have to be here to turn the function into 0? And if you can determine that, you have, usually you're going to have 2 of these x-intercepts. In this particular problem, if x was 2, you would have an x-intercept. Or if x was -6, it would lead y to be 0. You would have an x-intercept. Now to me, a parabola is kind of like you could do it on your face. Your eyes would be the x-intercept, your nose would be the vertex. So if you find x-intercepts on a parabola, the vertex has to lie right in the middle of the parabola, because it's got symmetry, it has to lie right between there. So if I found an x-intercept at 2 and I found one at -6, and I said, could you possibly figure out where the vertex point lies? It has to lie in the middle. So what's right in between -6 and +2? Well, if I came back, if I averaged those, I'd be right at -2. Okay? That's the x-coordinate at the vertex. It's going to lie right on that line of symmetry. Now if you put -2 in here, let's see what we get. -2 and -2 is -4. -2 and +6 is +4. They're multiplying. That would be -16. And the opposite of that would be +16. So at -2, I'm way up at like 16. That would give me an outline of that graph. Okay? Now, since it opens down, this becomes the maximum output. So the maximum output of this function is 16. Okay? So vertex form, it's a package. You can figure out the vertex of the parabola. X-intercept form, it's factored. You can find the x-intercepts, and from there, you can get the vertex, which allows you to answer what's the maximum or minimum of the function based on whether it opens up or down. Okay? That was pretty quick. That's a way of getting the vertex point, whether it's in standard form, vertex form, or x-intercept form. All right, we'll see you on the next video. Thanks a lot.